You might remember transforming graphs back in your precalculus course. So if you had a graph like y equals x squared, which is an upward facing parabola, you might remember that there are things you can do to the equation that will make it shift left and right and up and down. And there are also things you can do to stretch it vertically or compress it vertically, stretch it horizontally or compress it horizontally. And so we're going to take those same ideas and apply them to the sine and cosine functions. This word right here, sinusoidal, is just a word that refers to both the sine and the cosine function, and so it's often used in this place instead of saying sine or cosine. So transformed sinusoidal functions. There are certain features that we saw from the key values that we want to figure out what happens to those things on the transformed graph. And so the first thing we want to think about is the midline. So what is the midline? Well, the midline is the line that cuts through the middle of the graph vertically. The line that cuts through the middle of the graph vertically. And you can see that this thing is affected by the vertical shifting. So the midline is typically the line y equals 0, but if it's shifted up or shifted down, you see that shift, that vertical shift occurring to the midline. It gets shifted up or shifted down. Next we have the amplitude. Amplitude. So what is the amplitude? The amplitude is the distance from the midline to the peak or to the valley, to the min or to the max. And since this is a distance, we really want to think about this amplitude being a positive number, the distance from the midline to either the max or the min. And we say this distance here means the vertical distance up or down. Right, so that's the amplitude. And you can see that the amplitude corresponds to a vertical stretching. The initial amplitude of the basic sine and cosine functions is 1, because we think about the unit circle, right, and then we take those distances. And so if it gets stretched vertically, then we have more amplitude. If it gets compressed vertically, then we have a smaller amplitude. Next, we have the period. The period is the amount of time, well, I say time, but the amount of horizontal distance it takes to repeat. The horizontal distance to repeat. Right, and so this in the basic sine and cosine function is 2 pi, but if it's been stretched horizontally or compressed horizontally, that value will change. The thing that matters for the period is that we want to make sure we're looking for the function to repeat. Typically, it makes sense to look for maximum to maximum or minimum to minimum. You can also do sort of where it crosses the midline to the midline, but you want to make sure that you're crossing the midline in the same way. So measuring from here to here would not be the period, because you can see that the function is going up in this case and down in that case. So you'd actually want to measure from there to there or from there to there. But in any event, the period is how long the horizontal distance to repeat. And then lastly, we have the horizontal shift. Now the horizontal shift is a little bit tricky, not because the idea is tricky. Right, a horizontal shift is just how far left or right the thing has been shifted. But the problem comes from the fact that when you have the horizontal shift, you're asking the question, where have you shifted to get to the starting point of the graph? And it could be this one or this one, if we're looking at a cosine function, or it could actually be down here or here or here for sine functions. And so the horizontal shift is actually one of these things that's a little bit more nebulous, because it depends on how you understand the shape of this graph. And so I'm going to call it the shift to the start of the function. And when we get to the next section and start looking at the equations of this, we'll understand a little bit more what this means. But basically the horizontal shift just corresponds to taking your initial graph and shifting it this way or shifting it that way. And the confusion comes from the fact that this function is periodic, which means that it's going to repeat itself in different ways. And in fact, there's even more symmetry involved in this that gives us multiple different ways of understanding a particular graph. We want to think about the equation of a transformed sinusoidal function. Now we have here a sine function here, but it could just as well be a cosine function with everything else still the same, and it would be the same concepts. So when we think about a transform function, remember we have parts that make it shift left and right and up and down. We have things that make it stretch horizontally and vertically. And so we need to see how all those pieces fit into here. And if you're a little bit uncertain about this part, you can always go back to thinking about something like the graph y equals x squared. And think about your experiences with that to push it forward to help you understand this. So let's take a look at the different parts of this and see if we can figure out what's going on. We're going to actually start with the d. Now, if you think about x squared plus 3, you should imagine that being a vertical shift. And so d corresponds to the vertical shift, which in this case also corresponds to the midline of the function, right? Vertical shift shifts that whole midline up or down. The a is the next part we're going to look at. And the reason why we're going to look at this is because this continues in the sense of verticality. And it's going to be either a vertical stretch or compression, depending on whether a is bigger than 1 or less than 1. But a is the vertical stretch component. And it corresponds with the amplitude, right? The amplitude, amplitude, right? So the amplitude for the basic cosine or sine function is 1, and then if you multiply by a bigger number, it stretches vertically. If you multiply by a number smaller than 1, it gets compressed downward. The vertical and the vertical components, the vertical stretch and the vertical shift, those are the ones that most students tend to be more comfortable with. The horizontal part is a little bit confusing because there are a lot of little bits and pieces to it. First thing is when you look at this right here, you'll notice that it's t minus c inside of parentheses. Now, this c right here corresponds to a horizontal shift. And if you look around the internet, you'll actually find different equations for this. And in some situations, it corresponds to a horizontal shift, but not the exact amount. And so I'll show you what it looks like. It would look like bt minus c like this. If the t minus c is not inside parentheses, the horizontal shift is actually a different value. And that's just one of the annoyances of this thing. And so just pay attention to how it's presented. We're going to use this presentation here so that the c actually corresponds to the actual amount of horizontal shift. Which leaves us with b. b corresponds to horizontal compression. One of the things about this is that when b is a number bigger than 1, it's compression, and when b is less than 1, it's stretched out. And so this actually fits for both the minus sign here as well for the horizontal, is that the horizontal is just backwards. And there's a reason why it's backwards. I don't want to get into that right now. But b corresponds to the horizontal compression. I use the word compression here because when the b value is bigger than 1, you would think of it being compressed downward. And this relates to the period, but it is not the period. So I'll say not quite the period. And this is something that students often get confused by, because they'll look at a formula and they'll say, okay, the b is equal to 2, the period is 2. That's not quite how it works. It impacts the period, but the value of b is not actually the period. And so these are the different components in the equation of the transformed sinusoidal. You can see that we have the two vertical parts, the vertical stretch, vertical shift. We also have the two horizontal parts, the horizontal compression and horizontal shift. And so this puts together all the bits and pieces that will allow us to graph a transformed sinusoidal function. When reviewing the video, I realized that I didn't talk about what the period of the transformed sinusoidal function would be. I just said that this b value wasn't actually the period. So let's take a quick moment and discuss this. So this b value, it corresponds to a horizontal compression, but what does that really mean? Well, what it means is that if b is equal to 2, for example, it means that you're going to fit 2 periods in the same space that you would normally fit 1. So 2 times as many periods compared to the original. And in fact, whatever this b value is, it's going to be that times as many periods that it needs to fit into that interval. So the question is, well, what is that interval? And what does that mean that the new period is? Well, the sine and cosine functions, they're periodic with period 2 pi. So this is our baseline period. The new period is going to be this thing divided by b. So for example, when b is equal to 2, we're going to have, let's actually draw this out. So here's the standard interval from 0 to 2 pi. If we need to fit two periods into this space, we would cut it in half, and each one has a length of pi. And you can see that when b is equal to 2, that matches this idea. And so this is how that horizontal compression factor actually tells us what the new period is going to be. It's going to be 2 pi divided by that compression factor.